Welcome back to Car Academy. In this series of video, we are looking into CEC337 DSP architecture and programming as elective syllabus of Electronics and Communication Engineering, Anna University Regulations 2021. Okay, so in last video, we looked into the steps to download the Code Composer Studio from ti.com website. Okay, so CC Studio has multiple versions available, and we were basically looking into the CCS version 3.3. Okay, so once you click this downloads, it takes you to this particular location and you click download options. There are multiple versions of the software available: Windows, Linux, Mac. Okay, and we are interested in the Windows version, and we are also interested in the older version. So I was clicking this view all versions, and you can see different version of Windows EX executables. The latest one as of today is version 20.2, which got released a couple of weeks ago in June 2025. But for this particular curriculum, we are basically interested in the older version, which is basically version 3.3. Okay, so once you click this version 3.3, you will see this option CCS 3.3 platinum.zip, and you will be asked to fill a form in order to download this software version. Whereas the latest version doesn't have any such requirement. You can just download without even registering an account with ti.com. So once you register and get the approval, you will be able to download this particular software. Once you downloaded it and installed on your machine, you will basically need a Windows operating system of Windows 7 or lower. Okay, this software version cannot be installed on the latest Windows like Windows 10 or Windows 11. You need a older Windows version. So once you install this on a older laptop, I'm on Windows 7 right now. You will see these two icons available: setup CC Studio v3.3 and CC Studio v3.3 available after installing the software. So once you are installed, you basically double click the setup so that you will get the setup window. So the setup window will look something like this, and here you can see three tabs. One is system configuration, then you see available factory boards, then you will see my system. And we are not going to use any physical board, we are going to use the simulator. So you don't need any physical board in order to do all the experiments that we are going to do as part of this video series. So since we are going to use the simulator, select simulator in the platform, and I'm also interested in the little endianness. After that, I'm interested in doing on C64XX. Okay, so there are two processors which are basically in the curriculum. One is C54X and C64X. So I'm going to do it on the advanced version of the DSP processor, which is C64X. So I select C6416 device cycle accurate simulator. Once you select that, you can click add, which is actually not shown in one second, let me try to show you that. Okay, now you should be able to see. So once you select C6416 device cycle accurate simulator, you click this button add. Once you click this button, you will see the C6416 device cycle accurate simulator here. Now click save and quit once you are done. Okay, so this will open the Code Composer Studio, which is basically what happens when you actually double click the CC Studio. Okay, so now it opens the Code Composer Studio. So once you open the Code Composer Studio, you will see a window something like this. Okay, since it's an older laptop, I will have to basically make some changes so that you can see the whole window. Oops. Okay, I think now you can see the whole window. Okay, so now we are going to create a project in Code Composer Studio. In order to create a project, you can either, if you want to open the project, you can right click the project and click open. But since we don't have a project, we are going to create a new project here. Click project and then you can say new. Okay, and as part of that, I'm going to do something like arithmetic. This is my first project, arithmetic. Okay, and I say finish. Before you say finish, check where your project is going to be stored. This is the location where the project is going to be stored. Keep a note of that. Okay, copy this location in case if you want to refer later. This is the location you have to come and pick the project. And what will be the project type? It's basically an executable, which means that this executable can be run on a DSP hardware or on a simulator. Okay, so you'll basically get a .out file, and this is basically written for TMS320 C64XX processor, DSP processor. Then click finish. So once you've done that, you will see a project here, but nothing is there. Okay, only certain folders are available. Okay, now what we're going to do is we are going to write a program here. Okay, so this in this editor, Code Composer Studio is a integrated development environment. Why we say integrated development environment? Because we have the project, we can write code, we can actually compile the program here, we can actually run the program here. So everything can be done within the single window. Okay, that's why we call it as a integrated development environment. Okay, you can also debug the written program. For example, if your code has some bugs or errors, you can actually debug that within this window. So pretty much everything can be done here. So I'm writing a small function just to demonstrate the capabilities of Code Composer Studio. I have three variables declared, A, B, C, and A I'm assigning a value of 20, I'm assigning a value of 10 to B. So C equal to A plus B, I'm performing an addition. So here I'm doing %D plus %D is equal to %D \n A, B, C. Okay, so and then I'm doing a subtraction here, C equal A minus B, and doing pretty much the same, %D minus %D is equal to %D \n. So we'll see. Then C equal A times B, I'm printing the value, %D times %D is equal to %D \n A, B, C. Then I'm also doing the divide printf. So we have a very small program, very simple program to illustrate the capabilities of Code Composer Studio. Then I'm also going to do a modulo printf %D mod %D is equal to %D \n A, B, C, and finally return 0. Okay, now we read the C file. I'm going to save this file. So since my laptop is a little bit older, it's basically struggling to save my file. I wrote the code. It's gonna take a while to save the file. Okay, it's very old laptop, more than 12 years older. Okay, I don't know what's happening, but it's basically this window is not responding. Okay, now we got. Okay, so I'm going to save this code in the same place as where our project is. So you have this arithmetic. I'm going to store this in the same place, arithmetic.c. Okay, so this is saved. Now we need to add this to the source code. Okay, so add files to project and choose this arithmetic.c. So once you choose that, you will see the arithmetic.c under source, and we will also have to add another file which we call it as a linker file. This has this content. So basically I'm allocating a memory for heap. Heap is where you actually dynamically allocate. Heap is the memory where you can actually allocate memory dynamically. We are not allocating anything dynamically in this program, but this is basically a common linker script file. And I am also allocating some memory for the stack. This is basically where when you call a function, there are certain memories that's basically reserved for storing the local variables and things like that. So this is what stack memory is. And you also have a static RAM, which is basically a memory that's available internal to the DSP or pretty close to the DSP. O is nothing but the origin or start address, and L is nothing but the length. So you are defining that the static RAM origin is basically 0 and it has a length of so and so. When you say H, basically this is a hexadecimal number. And ext is basically an external memory. We call it as a DRAM, which is dynamic random access memory or dual data rate memory. This start address is 8000000H hexadecimal, okay, and its length is specified here. And within this, basically you are also specifying where your program is going to be stored, where your stack is going to be stored, where your global variables are going to be stored. This is basically, we'll go through this detail in the upcoming videos, but basically a linker script is a must while you're building a program for a DSP or any embedded boards, embedded processors. Okay, so this is something we need, and I'm going to store this again. Here I will say this as a linker command file lnk.cmd. We'll have to add that as well to our project. So I'm going to say source add, and here you basically select all files. You will see that lnk, add that file, and now you basically save that project once you added that. So all these files are basically added to the project. Now we can build the project. Okay, so there's a button rebuild all, click that. Okay, it's located here. So I did not see any errors here. So 0 errors, 0 warnings, and 0 remarks. Okay, so the program built successfully. Now we need to load this program. This program, if you have connected a hardware board, this program will be loaded onto the DSP processor. Since we are running on the simulator, this will be basically loaded onto the simulator. So load program, here you will find a debug, and during the project creation, we said our executable is a .out file. Our output is a executable.out file. So this is nothing but the file that got created from our program. So select this and load. So c underscore int 00 is nothing but the main function. Okay, so once you load the program, it basically you should see an arrow next to c underscore int 00. Okay, now we can also say something like this. Okay, in under debug, if you click go main, you will see the arrow here. Okay, and you can also see something special here. There is something called mixed mode. Okay, when you right click here in this, after loading the program, this option will be enabled only when you only after you load the program. So when you click this mixed mode, you can see the assembly code of your C program. Okay, so you can see a equal 20, 0x010014 is nothing but the hexadecimal value of 20. Okay, that's been stored in the register B4. And here you see b equal 10. So this is not stored in the hexadecimal, this is but just the decimal value being stored in the B4. And you see here c equal a plus b. You can see add assembly instruction here, okay, in this line. And you are seeing one of the values in B5 and the other values in B4. You are basically adding two registers B5 and B4 and storing the output in B4. Okay, and finally you are printing the result here. And you can also see here we are doing c equal a minus b. The values are already in the register, so we're not doing much like the previous case. So the values are still in the B4 and B5. Now you can see there is a sub instruction for the subtraction. Okay, so again the result is basically stored in the B4. Your SP is nothing but the stack pointer. So basically the values in the stack pointer are pulled into the register here. Then you can see for the multiplication, you can see MPY. Okay, there's a we'll look into the assembly later, but I'm just trying to show you that you can actually look at the assembly instructions for our C program. And for the division, you can see there's no division operation, but basically it does something like add, or, and it uses other instructions to actually do the division. And for the modulo, you can see something like, again, add and things like that. Okay, so there is no modulo assembly code. Similarly, there is no division assembly code. It uses other instructions to calculate the division. Okay, now let's go and run the program. So here you see there's someone running. Okay, when you move your mouse pointer on top of this icon, you will see run. Now click run. When you click run, you can see the output below. See, now we wrote the program, we built the program, we got the output, everything in this tool. That is why this is called integrated development environment. So I think what happens is, for the modulo, we did not get the right output. Okay, so for addition, 20 plus 10 equal 30, 20 minus 10 equal 10, 20 times 10 equal 200, 20 divided by 10 equal 2. And for the modulo, we did not get the right output. Okay, let's go and fix that. That's also important. We need to fix that. Okay, so in order to fix that, I know what's happening. So let's disable this mix mode. Okay, go to the source mode. Now you did not get the proper output because percentage is basically considered as you're trying to print something. Okay, when you try to put double percentage, it means that the compiler thinks that you're trying to print a percentage onto the output window. So in order to get rid of that, there's a escape sequence you can say. Okay, so I want to print this percentage. Let's see now. Let's rebuild. So we it says an unrecognized character, but let's say, okay, there's one warning. That's fine. Let's load program. So we loaded, and let's go and run. Click run. So after clicking run, you're still seeing this problem. So what we will do is, now let's try double percentage and see what happens. So rebuild. Now we did not see that error or that warning. Now let's load and then click run. Now you see 20 modulo 10 is equal to 0, which is the correct output. Okay, so if you want to print this percentage, you will have to basically type it twice to fix this problem. So I think you might have got an idea on how to set up the Code Composer Studio, how to write programs, how to debug issues, how to get the output. There are several things that can be done with the simulator. We are going to see one after another in our upcoming videos, but I think this is a very good starting point for you. I hope you like the video. Like this video, and then subscribe to the Core Academy channel. Share it with your friends. We are making videos not just on DSP but on several emerging technologies like artificial intelligence and other programming techniques. So follow our channel for getting the latest updates. Till I make the next video, I'm signing off. Bye.